Okay, now in order to better understand the lessons and the tutorials you learned so far about trig transformations, we're gonna solve the problem so you can see how we can apply the method. Let's say, for example, we have 2 sine of 2x plus pi over 3 plus 1, and we want to graph this trig function. What we want to do is we first want to break the transformation into several steps in order to we get to the full function which is mentioned in here. So we're gonna start with the sine of x. Then we're gonna change this sign to sine of 2x. And then we are gonna change this sine of 2x to sine of 2x plus pi over 3. Then we're gonna change this one to 2 sine of 2x plus pi over 3. And then at the last stage, we're gonna change this to have a plus 1 at the end. You see in here, the transformation of the graph was actually initially started with the sine function, which is the fundamental function for the t transformation. And we made some changes to sine of x, so we could eventually get to the desired function on the question. Okay, now in order to accurately draw the final function, we should graph each transformations step by step. To do so, I'm gonna first illustrate what each of these transformations do to the function so we can visualize them better. So, as you see in here on the first step, there is a coefficient of 2 multiplied by x, which is this coefficient is actually b. If this coefficient was bigger than 1, if you remember from the previous videos, the function would be compressed horizontally. I'm going to show it by this direction, and it's going to be compressed horizontally by the factor of 1 over 2. Now, let's look at the second stage. As you see in here, there is a phase shift happening in here, which is variable is equal to c. If c was bigger than 1, was bigger than 0, which is a positive value in here, it means that the function is going to be shifted to the left by this value. So, shift to this direction by the value of pi over 3. Now, on the next stage, as you see in here, there is a coefficient of 2 applied and multiplied to the whole function. And this value is actually our a value on the transformation function. And what it does is going to actually stretch the function vertically by this value. By the value of 2. Now, on the final stage, as you see in here, there is a plus 1 added to the whole function. And what it does, which is our d in here, what it does is going to actually shift the function vertically by this value. Shift to the upside, since d is a positive value, by the value of 1. Now, after knowing what each of these transformations do to the function, we're going to start drawing them step by step. Remember, in order to get to the final function, we should start from drawing sine of x, then we're going to proceed to drawing sine of 2x, then we're going to continue, so we eventually get to the final function. Now, let's say we want to start from sine of x. As you remember from the previous tutorials, the sine of x graph would look like this, which it oscillates between 1 and minus 1, and it had the intersection with the x-axis at pi, and also its maximum value was at pi over 2. So now we want to draw sine of 2x from this fundamental function. As you remember, the second step is sine of 2x. Now, in order to draw this graph, we should compress the function horizontally by the factor of 1 over 2. So that means we should divide each of the values of x in here by 2. So if I, for example, divide 2 pi by 2, it would give me pi. If I divide pi by 2, it gives me pi over 2. So I should move 2 pi, and also I should move pi to pi over 2. So the function would be, seen here, I'm moving 2 pi, I'm moving the right pawn to pi. And at the same time, the pi would be actually moved to pi over 2. So this would be the sine of 2x function. Now, we want to derive sine of 2x plus pi over 3. So we should shift the function by pi over 3 to the left horizontally. So I'm going to choose the function now. I'm just going to shift it by pi over 3. Pi over 3 is around 60 degrees. So, and it is, if you remember, this point was pi over 2. So if I want to move it by pi over 3 to the left, it would be less than this value. It would be looking like this. So the 0 point on the x-axis, which was the origin, now it is going to be moved to minus pi over 3. And also all of the points that we mentioned here, for example, this point was pi before on sine of 2x. Now it is going to be pi minus pi over 3. And this point, for example, was at pi over 2. So this point is now going to be pi 2 minus pi over 3. But the point is that we want to just visualize the graph for now. We're not calculating the x-axis values. So if you want, you can do this at the home and you're convenient. But for now, we're just illustrating the graph. After drawing the sine of 2x plus pi over 3, now we want to proceed with 2 sine of 2x plus pi over 3. So that means we want to stretch the graph vertically by the factor of 2. So that means the y values now would be moved to 2 and minus 2. If you see in here, our y values is at maximum is equal to 1 and minimum is equal to minus 1. So this point would be actually transferred to 2. So it will be around here. And this point would be transferred to minus 2, which would be around here. Now, in order to get to this point, I'm just going to stretch it vertically. I'm not going to shift it to left or right. Just going to move the maximum value to 2. It would be looking like this. And also at the same time, moving the minimum value to minus 2 as well. So our final graph is looking like this. Now, at the final step, we want to draw and we want to include the d factor in here. So as you see in here, this d, which is a plus 1 in here, it means that we should shift the function upward by 1 unit. So I'm just going to choose the graph in here. And I'm just going to shift it upward by 1 unit. What does it mean? It means that the minimum value, which was at minus 2, now it is going to be transferred to minus 1. And at the same time, the maximum value, which was at 2, is going to be transferred at 3. So it would be, let me just move this upward by 1 unit. And remember, we are not going to shift it right or left. We're just going to move it upward by 1 unit. So it would be looking like this. And this point on the maximum value would be equal to 3. So if I extend the y-axis in here, this point on the y-axis would be equal to 3, which is the maximum point of the graph. And the minimum point would be equal to minus 1. So we could successfully draw the last part as well. The only thing that we should do now is that the sine function is a periodic function. So it is going to repeat itself onto the left side and onto the right side. So we should actually copy this function and just paste it to the right side and onto the left side as well. So if you paste it on the left side, you can see the intersection with the x-axis as well. So I'm just going to copy this function now. And I'm going to paste it onto the right side. Which would be exactly looking like this. And also to the left side, which would be looking like this. So our final function would be looking like this. And if you want to find the x values or the root of the function, we can actually calculate these step by step, or you can easily solve this equation and just equal this equation to 0 and just find the roots in here. And we also found the maximum minimum values in here as well.